All right, hi everyone. This is lesson 3, Earth's movements, divergent plate boundaries. Last time we talked convergent plates, and now we're talking divergent plates, and let's refresh kind of where we started with convection. Okay, so with convection, we had this hot magma rising. We were thinking about this upper mantle asthenosphere. You had this hot magma rising, and then it will move across underneath the surface of the crust, and then it'll cool down, and then it'll sink. And so you have this happening all over the world. And where this hot is rising is in these gaps of these plates. And so when you have hot magma rising in the gaps of these plates, what's going to happen is it's going to shift the plates and push them away from each other. So you see here where this heat in this magma is rising up to the crust, it is being pushed out to the side. And so you have a divergent plate here. And where that magma kind of comes back together and away from that push is where you have your convergent plates, and you have magma becoming more dense and falling under, and that kind of gives us our different kind of features of convergent plates. Our root word here is to diverge, and to diverge is like to go away from something or to go a different direction. And so a divergent boundary occurs when two tectonic plates move away from each other. Along these boundaries, earthquakes are common, and magma or molten rock rises from Earth's mantle to the surface, solidifying to create new oceanic crust. You also have a lot of volcano activity. You're going to learn about volcanoes in this lesson. So you have also new oceanic crust being created because the magma is going to rise to the surface, but it's underwater, so it's going to cool very quickly, and it's going to harden and create new lithosphere. So you have two types of divergent plates. You have continental versus continental and oceanic versus oceanic. So our first one is continental versus continental. When you have two plates that are continental plates that are moving away from each other, you get this feature called a rift valley. New lithosphere is being created because magma right here is being pushed up, and it is going to start pushing these plates to the side. So here's one plate over here, here's one plate over here. As the magma pushes up, it's going to not have room, and so it's going to push them away from each other. So you see this away motion here. An example here is the East African Rift. I'll get to that one first. In Africa, over here in East Africa, you have, we're looking at kind of Kenya here. You have this East African Rift. You have a plate tectonic that is moving away from each other. And you have big rifts in the middle of like desert. This is a rift valley, and you can see these big rifts that are happening in Africa because two tectonic continental plates are splitting up and moving away from each other. Eventually, they're thinking that this could be another ocean because it's going to split up so completely that another ocean will be forming, because with these big trenches, you have rainfall and water is going to fill those things up. Another example is Iceland. Iceland is splitting in half as well. It is on divergent plates. You have your North American plate and your Eurasian plate, and in the middle of Iceland, it's kind of getting caught up in this mid-Atlantic ridge that we're going to talk about next. But there is a part of Iceland, and it is splitting completely in half. And so with that, you see some volcanic activities. The little triangles are for volcanoes. You have magma coming up to the surface because there is a break in the surface. So Iceland is splitting apart, and you can see that here you have like these roads in the middle of these rift valleys, and you can see these big trenches, and they're very, very deep. And underneath it, there are all kinds of magma pushing up in the earth, and it's going to solidify and create new land for us, but it is moving Iceland apart. So our next type is oceanic versus oceanic lithosphere, and this is where you have two plates under the ocean, and it is once again your North American plate and your Eurasian plate. So these two plates, and it's going to create this ridge in the middle of the ocean. So you get these mid-ocean ridges you get rift valleys. You're creating new lithosphere. And so as the magma cools and hardens, new lithosphere is being created. Your example here is the Mid-Atlantic Ridge. So you have magma being pushed up right here, and you have the plates being pushed away from each other, and you have new lithosphere being created here, and it creates this mid-ocean ridge. Here's a picture. You have this Mid-Atlantic Ridge, and it goes all the way through the Atlantic. It's very deep. And you have like it kind of going all the way through, and then it will go up and like through Iceland as well. And this is kind of what it looks like underwater. It's a little deeper than this in different parts. Some parts are shallower, but you can see these big rock formations being shifted away from each other. So that's your overview of divergent boundaries. You're going to go ahead and move on to the assignments where you're going to learn about volcanoes and about some other divergent plate boundaries. Have a great day.